Metallographic sample preparation of welded joints on the top cover of aluminum battery shells. Welding of aluminum shell top covers for power batteries of new energy vehicles. It is a key sealing process in the manufacturing process. The micro-quality of welded joints directly determines the long-term sealing performance, internal pressure resistance, and safety of the battery. The following is the metallographic sample preparation process for aluminum alloy welding. First step, cut and sample. Use the truly precision cutting machine to cut and sample the battery case top cover. Minimize the changes in microstructure caused by thermal effects and mechanical deformation. The finally intercepted sample should contain a complete weld cross-section with appropriate dimensions for embedding. The second step, mounting. To protect the fragile weld edges and multi-layer structures, and achieve rapid sample preparation using the ultraviolet curing cold mounting process. Inject low-viscosity UV curable resin to ensure that the resin fully impregnates the edges of the sample. Subsequently, the mold is placed in a UV light curing machine and irradiated for 60 seconds. Make the resin cure quickly to form a high transparency, inlaid sample. This method avoids the thermal influence that hot press embedding may have on the microstructure of aluminum alloys. The third step, grinding and polishing. Grind sequentially using silicon carbide sandpapers with grit sizes of P400 to 2500. Each time you change to a new grade of sandpaper, the grinding direction should be perpendicular to that of the previous grade, until the old scratches are completely replaced by new ones. The purpose of this stage is to obtain a flat macroscopic surface with uniform scratches. For rough polishing, use the flexible SC silk polishing pad plus 3 micrometers polycrystalline diamond polishing fluid. Fine polishing uses a highly elastic ZN damping polishing pad plus 0.05 micrometers alumina polishing liquid, Keller's reagent for light etching. The prepared samples were observed and analyzed under a metallographic microscope. A large number of welding defects, such as pores, were observed inside the weld metal. Stomata and holes are serious defects in the welding of lithium battery shells. They directly damage the tightness of the joint, which may lead to electrolyte leakage seal failure, and it brings the risk of thermal runaway due to increased local current density or the initiation of internal short circuits.
Trojan. Discover the truth of material.